While Lockheed conquers the sensors, Boeing is diving deep with a new Titan. Welcome to Boeing's undersea ambition. The skies belong to them, but now they're diving into the abyss. This is the new front.
Strategic Forecaster, domain of the Titans. Boeing's undersea gambit. Here we go.
The global defense landscape is experiencing a tectonic shift as warfare expands into increasingly contested environments. In our previous video, we explored how Lockheed Martin is aggressively securing the undersea kill chain, moving beyond composite hull research by agreeing to acquire Maritime to control the acoustic sensor supply chain. Now, another aerospace titan is executing its own calculated descent into the world oceans, but with a fundamentally different tactical philosophy. If Lockheed Martin is racing to own the ocean digital nervous system, Boeing is quietly assembling a muscular skeleton, one built on physical scale and long-range robotic endurance. This strategic pivot is a direct response to the urgent geopolitical realities of modern maritime denial, where operating beneath the surface provides the ultimate sanctuary of stealth. The evolution of naval doctrine toward distributed operations requires a new breed of autonomous vessels capable of fighting without putting human sailors at risk. Boeing is capitalizing on a structural deficit within the US Navy, which currently faces a severe shortage of attack submarines and shipyard maintenance capacity. Unlike Lockheed Martin's focus on the expendable sensor market and anti-submarine warfare tracking, Boeing has positioned itself as a direct manufacturer of massive, fully autonomous underwater platforms. By looking beneath the surface, Boeing is redefining its aerospace identity to master a domain where traditional communications cannot reach. Consequently, this giant of the skies is betting big on the strategic importance of absolute, independent underwater presence. Boeing's successful foray into the maritime industry was not built upon a sudden whim or a massive corporate acquisition, but on a decade of disciplined internal research. The true catalyst for their undersea development is the Echo Voyager, a pioneering prototype entirely funded and developed by the company since the early 2010, publicly unveiled in 2016. While Lockheed Martin newly updated maritime strategy relies on integrating ultra-maritime sonobuoys and acoustic arrays into lightweight hulls, Boeing's core strength lies in localized artificial intelligence and deep-sea navigation. The Echo Voyager proved that an uncrewed vessel could operate completely independently without a manned host ship for launch and recovery. By developing sophisticated autonomy algorithms, Boeing achieved an engineering milestone that few traditional naval builders had demonstrated at similar scale. The transition from a laboratory prototype to a military-grade weapon system required a profound mastery of long-endurance propulsion. Boeing engineered a sophisticated diesel-electric hybrid system that allows the 50-ton Echo Voyager to travel up to 6,500 nautical miles at economical cruising speed before returning to port. When the batteries drain, the vessel comes to periscope depth, raises a snorkel, runs its diesel generators, and recharges its power cells autonomously. This self-sustaining capability contrasts sharply with Lockheed's approach of deploying expendable sensors or smaller, attritable surface platforms. By proving that a 50-ton machine could safely navigate the open ocean completely alone, Boeing convinced military planners that aerospace-grade autonomy belonged in the deep ocean. The core design philosophy behind Boeing extra-large unmanned undersea vehicle, the Orca, centers on unprecedented scale and modularity. Weighing over 80 tons with its payload module installed, this underwater heavy lifter features a massive, customizable payload bay capable of carrying up to 8 tons of equipment, equivalent to dozens of smaller drones or a significant mine payload. While Lockheed Martin controls the supply chain for sensors that hear quiet submarines, Boeing is building a submerged cargo fortress designed to carry versatile mission packages. Boeing bypassed the limitations of traditional single-purpose naval design by treating the hull like a cargo aircraft, creating an adaptable space that can rapidly evolve alongside changing threat environments. This modular approach ensures the vehicle remains a versatile military asset for decades without requiring a complete structural overhaul. In its initial deployment phase, this massive payload capacity is being utilized primarily for mine warfare missions. Defense analysts suggest that potential payloads could include offensive miner laying, electronic warfare suits, advanced sonar arrays, and even smaller drone swarms, but the Navy has been cautious in detailing exact operational roles. By providing a flexible underwater mothership, Boeing allows the military to swap capabilities between missions in a matter of hours. This structural versatility effectively shifts the burden of naval adaptation from expensive steel modification to rapid software and payload integration. It is worth noting that Boeing faced significant production delays and software integration challenges during Orca development, yet the first units were finally delivered to the Navy in late 2023, marking a pivotal milestone after years of testing. Entering the undersea market represents a vital strategic lifeline for Boeing, especially as its commercial aerospace programs face intense scrutiny. However, examining both aerospace giants reveals two entirely different philosophies for conquering the maritime domain. Lockheed Martin is executing an aggressive data-centric strategy, buying up companies like Maritime to own the sensors, sonobuoys, and digital kill chains that track enemy assets. Boeing, on the other hand, is investing heavily in heavy physical machinery, focusing on massive, long-endurance underwater platforms that operate completely hidden from sight. Lockheed wants to be the ultimate listener and systems network integrator. Boeing wants to be the ultimate heavy lifter of the silent depths. However, this underwater robotics race is not a two-horse contest. Competitors like Huntington Ingalls and Dural, an Australia Ghost Shark program, are all pursuing similar XLUUV capabilities. Yet Boeing's deep aerospace pedigree in satellite communication and autonomous flight control gives it a unique edge in integrating these submerged assets into the Joint Force Network, not through direct satellite links while submerged, but through acoustic relays, gateway buoys, and carefully timed communication windows when the vessel surfaces. When those windows open, Boeing can leverage its experience in networked aerospace systems to connect Orca with satellites, aircraft, and command networks above. However, this underwater robotics race is not a two-horse contest. Competitors like Huntington Ingalls and Dural, an Australia Ghost Shark program, are all pursuing similar XLUUV capabilities. Yet Boeing's deep aerospace pedigree in satellite communication and autonomous flight control gives it a unique edge in integrating these submerged assets into the Joint Force Network, not through direct satellite links while submerged, but through acoustic relays, gateway buoys, and carefully timed communication windows when the vessel surfaces. When those windows open, Boeing can leverage its experience in networked aerospace systems to connect Orca with satellites, aircraft, and command networks above. Ultimately, Boeing's deep dive is about connecting the underwater world to the Pentagon overarching vision of a unified, multi-domain command system. While Lockheed Martin masterfully buys the ears and sensors to dictate how Allied forces monitor the ocean depths, Boeing brings the long-range cargo capacity and autonomous brains of aviation to the sea floor. Through this comprehensive approach, Boeing is successfully transforming itself into a key player in autonomous undersea warfare. Both titans prove that the future of naval warfare is no longer being decided by traditional shipyards, but by the aerospace companies that once only ruled the skies.